So the first thing I noticed on number 1 is the old classic wants to fence in his backyard. Guys, this is absolutely old school. If you're going to fence in the backyard, what geometric concept is that? Perimeter. How do you find the perimeter of anything? Add up all the sides. That's the easiest definition of perimeter. Add all sides. Now, I can tell you right now that that was the biggest mistake made on this problem, was that you did not add all sides. What shape is this fence? It is a rectangle. How many sides are on a rectangle? 4. You should have accounted for 4 sides. Many of you only accounted for 2. You only did the length and the width. But you recognize there should have been 4 sides. So as you go through your work, you recognize that they told you something special about the length. The length was exactly double the width. So you knew in order to find the length, you had to take the width times 2, right? And they gave you the width right here. So I'm not going to do it for you, but you know how to do that. When you do that, you do get an answer. And guess what? That answer is 1 length. Some of you stopped and used that one single length and said it was the whole perimeter. Is it the whole perimeter? No, that's only one piece out of 4. So remember, on a rectangle, you're going to have to add 2 of these lengths. So you can either add another length, or you could multiply it by 2 and get both lengths. It doesn't matter to me. Either way you want to do it. But again, the number one thing was we did not get all 4 sides. So you need 2 lengths and 2 widths. Now here's your length. Your width was in the problem. That will give you your perimeter, right? Now, somewhere in the middle, I know I've kind of made a mess of things, but somewhere in the middle here, it says that you have this much fencing and you're going to have leftovers. Okay? How are you going to find out the leftovers? You're going to take the amount of materials that you have and subtract the perimeter of the fence. And that should be your answer. Okay? Tried to set you up for success on this one. It says the volume of a rectangular prism is found by multiplying the area of the base times the height of the prism. I told you the formula. Volume equals multiply the area of the base, which in geometry we would say is big B, times the height of the prism. Now, if you knew that formula, that's fantastic. If you didn't, who cares, because I gave it to you in the first sentence. What shape is the base? Rectangle. How do you know that? Because I said it. No, don't even look at the thing. Read. If the rectangular base, I told you it was a rectangle. So how do you find the area of a rectangular base? Length times width. What do you think 3a squared b and 6ab to the third c represent? The length and the width. So what should you be doing with these two? Multiplying. So you're going to multiply those two together. Now this is exactly what we did at the beginning of class. This is your laws of exponents. When you multiply like bases, what do you do with the exponents? Add. So this should be add exponents. And many of you messed that part up. Okay? But that's not the final answer, because you're supposed to take the length times the width and then multiply it times the what? Height, right? And they gave you the height as well. Where's the height? Right here is the height. So the height goes right here. But now the height is different from the length and the width. It's a binomial. So what are you going to have to do? Distribute. That's exactly right. After you multiply these two together, you will have a monomial times a binomial. And in order to multiply that, you have to distribute to both terms. And some of you did not distribute to both terms. We recognize what shape is that window? How do you know it's square? Because I told you. What do you know about squares? All four sides are the same. So even though it wasn't labeled, you know this is 2x plus 3, and this is also 2x plus 3. Now, I'm asking you for the paintable area of the wall. So what kind of problem is this? Is this a perimeter problem? No, it's area. I said it right there in the problem, right? So what's your plan? Plan is to take, okay, a generic plan. I like the way he said that. He said you're going to take the area of the rectangle or the wall, and you're going to subtract the area of the square, which is the window, right? Now you're being more specific about how to actually do area, right? How do you find the area of a rectangle? Length times width. How do you find the area of a square? Okay, it's still really length times width, but they're the same, right? So you've got length and width. Did I give you length and width?
Yeah.
I sure did. Here's the length and the width of the rectangle. Did I give you the length and width of the square?
Yeah.
Yes. Now this one over here, the rectangle, this is a monomial, this is a binomial. What do you have to do when you multiply? Distributive property. And once again, I can't tell you how many people did not distribute the 4x to the 5. Think about that. Think if that's you. Did you multiply 4x times 3x and get 12x squared, but you forgot to do it times the 5? Many of you did. Many of you did. And then you've got over here, and then you've got like terms. So this is going to be FOIL. And then after you're done with that, you'll do like terms, and you'll be done. Looking at this, this entire page was division. The first one, what is the divisor? What kind of polynomial is it? It's a monomial. You remember what to do with monomials? Fractions, that's correct. So these should all be fractions. And most of you did the fraction part of it, but you also end up with a negative exponent, and that's not cool. No negative exponents. All right? So what I need to know is this. I need to know, and you guys can figure it out on your own. I'm going to make up an example. It is not the same as this. It is just a random example. Is there a difference between 8? I can't use 8. Hush. All right. Can I use an example like 5 over q squared or q squared over 5? That's supposed to be an or 5q squared, or 1 over 5q squared. Those are all different. Different. You need to be very specific in your answer, especially with this last term, with which one it is. And some of you were not careful with that. So please just be careful with that. Look up your laws of exponents. Look up negative exponents. That's the word you need. Look up negative exponents. The rest of this was long division. You had lots of examples in class. Most of you actually did a pretty good job with this. You made little errors right in the middle. Those were your computational mistakes that I mentioned. Doing things like -3. How about 5 minus -3? I think that was one of them. 5 minus -3 is 8, not 2, right? So we just have to be careful with those. So I tried to give you some points for doing the process right, but ultimately you got to do the whole thing right. On number 7, I just would remind you, did you use a 0 placeholder? Some people did, and then some people didn't. Number 7, you need a 0 placeholder. The other two are pretty straightforward. They're really not hard. I was very pleased with number 8 that most of you, 90% or more of you, recognize that to be a factor, the remainder must be 0. If the remainder is 0, it is a factor. If the remainder is not, then it is not. So your job is to show your work and then interpret the remainder. That's your job. And then on number 9, you recognize that area equals length times width. Well, I gave you the area and I gave you the width, so how do you find the length? You would divide area divided by the width, and most of you did okay with that too. We spent a lot of time looking at end behavior in that section. I think it's, oh my goodness, chapter 6, section 4 or 5. But check out the end behavior there. There's not a lot I can say about 10. Number 11, I will remind you that is an odd degree. what do odd degree functions look like, and I'll remind you that the leading coefficient was negative. Some of you forgot that it was negative, and way back from the first week of school, what does a negative a do to a function? Flips it over the x. So whatever you ended up with here, don't forget you have to flip it before you figure out the end behavior, right? So some of us forgot that part. Starting with number 1, what degree is the polynomial? How do you determine degree? It's one more than the number of curves, right? That's the minimum degree it could be. It could be multiples over that, but the minimum degree is one more than the number of curves. So just count how many times this thing curves. Remember, we did a lot of those together. If it curved 1, 2, 3, 4, 5, 6 times, what degree would this guy be? The one that I just made up. This would be a degree 7 because it curves 6 times. So you have to read this graph and count the curves. Okay? With the same thing, think about that as far as 14 and 15 go. However many times it curves is the number of maximums and minimums you have. This particular one, this example I just made up, curved 1, 2, 3, 4, 5, 6 times, which means it has 1, 2, 3, 4, 5, 6 minimums and maximums. So if you will look at this curve, there is minimums and maximums, and there's more than one. So you have to think about what they mean. Now, some of you got real specific, and that was cool. I'm glad you noticed the equation down here, and you actually typed it in your calculator, and you computed the mins and maxes. That's fine. I was really just expecting an estimate. But that's totally cool that you did that. Either way works for me. Okay? But that's going to be 14 and 15. Roots, I can't talk too much about roots. That's too easy. Roots are zeros, and you just need to look that up because you're supposed to know roots. All right? There's 4 different words for roots, and this is 3 of them. It's the last one that you need to know. Okay? And then finally, the bottom down here, this was calculator work, and most of you did pretty well with this, but a reminder, if you want to find the roots, then you need to do second trace. So if you missed these, do a second trace number 2. And if you missed these, you want second trace number 3 and number 4, depending on which one you want, max or min. But that's straight out of the calculator. Guys, I can tell you what happened on 21. So many of you missed this on 21. You got all the roots right. You did a nice job. You made it even. You did a nice job, most of you. But this word right here, you died at maximum. All right? It says a maximum at x equals 5. Many of you came up here to the y-axis, even though this says x. You came to the y-axis, and you made it come up to 5, and you thought that that was the max. But that's not what I asked. All right? This is not what I asked at all. I asked you to make sure that the maximum happens when x equals 5. Now, did I say how high to make the maximum? No. You could have made it this high, or this high, or this high, or super steep, or even way down here. It didn't matter, as long as there was a hump right on the 5. So you put it in you interpreted what was going on wrong. So with the maximum at x equals 5, it should have happened here on x equals 5, and you should have had a maximum. Now the rest of it, you want to continue to make sure it's even, so make sure the end behaviors are both the same. That was ugly. Make sure the end behaviors are both the same, either like this or like this. And make sure it touches the roots at the right spot. Almost everybody got the roots and the end behavior right. It was that part. 22, you got a question about that one?
Yeah,
There's not a lot I'm going to say about 22 and 23. These are, and this one, these are the computational mistakes that we went over at the beginning of class. Okay? You have to be careful with it. I will say that with the negative, if you raise right here, if you put a negative in if you put a negative in to the fourth power, use parentheses. Any number raised to an even power will always be positive. And many, many, many of you did not use parentheses here. And consequently, here and again here, you ended up with negative terms, which totally messed the whole thing up. On the second one, most of you set this up correctly, but this right here, the 4 parentheses 2ab squared parentheses, is it a third? I can't see it. I think it's a third. Okay, just this part right here, some of you multiplied 4 times 2 first. You can't. The 4 is on the outside. You have to do the 2 to the third first, and the a to the third, and the b to the second to the third, which of course is a 6, right? And then you can multiply it times 4, and then you can do the rest of it. Down here, you end up with 2 parentheses h plus 1 squared, and we just talked about this. This is a FOIL problem before you multiply it by 2. Last thing to share with you, all right? Corrections due Friday, okay? Plus 5 for any math teacher signature.
I'm going to Miss Brown.
Any math teacher signature. Middle school, Mr. Schreiber. All right.